All right, I wanted to go over some of these, especially in case you're at home working or maybe I'm out or something, so you can keep going without me. All right, we're looking at the distance formula worksheet. There are two ways to do distance formula problems. One of them is to use the distance formula. And so in order to kind of show you that, I'm going to start with number 7 down here using the distance formula. I'm going to save the graphs and show you that a lot of times with a graph there's an easier way to do it. Now the distance formula is the square root of the differences in the x's. So what you're going to do is you're going to subtract your two x values and you're going to square it. That's an x there. Can't really correct it very well. And then you're going to add in the differences of the 2y squared. This actually comes from the Pythagorean theorem, and that's how we're going to do the ones on the graph. I'm going to show you. There's a much easier way to do this on a graph. So what you would do, for instance, is take 2 points like we have in number 7, and you're going to label them. So let me write the points down that I have. I have on number 7, I have -2 and 3, and then I have -7, -7. And so I'm going to label these. I'm going to say, okay, I'll call the first one I wrote down my first point. This is the x of my first point, and this is the y of my first point. It's supposed to be a 1, okay? On the second point, I'm going to say, hey, this is the x value of my second point, and here's the y value of my second point. Okay, so now all you got to do is plug it into the formula, and I'll do that in blue. Again, this is number 7. And sometimes we like the formula. Like right now, this is a great time to use the formula because I have points I can plug in. So I'm supposed to subtract the two x's and square them, and then I'm going to subtract the two y's and square them. I like to do this because you know what? I'm going to be plugging in some negatives, and it might be easy to think that I already put the negative on something, but there's subtraction signs in this formula. It just messes people up. So if you'll kind of write this out first and then go look at plugging stuff in. Okay, my x2 value was -7. I'm just going to use different colors here. My x1 value here is -2. Okay, I'll simplify that in a minute. My y2 value right here, oh, there it is, -7. I labeled it. And my y1 value that I'm supposed to use in my formula, so I always write my formula down, then I write these blanks. Now I've got something to follow. My y1 value is this 3 here, so I've kind of color-coded it so you can see where everything is and where it went. Okay, now that I've got it down, I'm just going to simplify it. Now -7 minus -2 becomes negative. Two negatives make a positive. Okay. I'm going to go ahead and just work with that little piece, and I'll go back and pick up the part after the plus sign, okay? -7 plus 2 is -5, and I'm going to square that. When I square -5, remember, a negative times a negative is a positive. When you square a number, whether it's positive or negative, it always ends up being positive. Okay? Copy down my plus sign. Now let me go back and work on this other part up here, the second parentheses. -7 minus 3, it's like I borrowed $7 and I borrowed 3 more dollars. It's like I borrowed $10 in all. That becomes -10 squared. Okay. Well, when I square a negative, it becomes a positive, so that's actually 100. So 25 plus 100 is 125. So my distance is the square root of 125, but we never really, we need to simplify that, so let's go ahead and simplify it. If I went and prime factored, and let me come off to the side, I'll just use this area over on the worksheet to prime factor. For those of you who have trouble with this, you could say, hey, it's 25 times 5, and I can take the square root of 25, and it becomes 5 square roots of 5. For those of you who are not, thinking that way, well, you can see it ends in 5, so you can divide 5 into it. 5 goes into 125 25 times. Oh, 25 is 5 times 5. So if I prime factor it, it's 5 times 5 times 5. Okay, and remember with square roots, you're looking for 2 of a kind. Here, there's 2 5s. I'll just start with the first 2. So when I see 2 of them, I can say, hey, they're going to the square root dance. I pull them out as one couple. I would write 1 5 down. Why am I saying that silly little analogy? To kind of explain to you that 5 times 5 is 25, and the square root of 25 is 5. I would bring that out of the radical, but I don't have another one to pair this 5 out with. So my distance there would be 5 square roots of 5. Using the formula when you have points is great. And you really need to know how to use the formula. So even though I'm going to show you another way to do it, I would do all the ones with points down here with the formula just to make sure that you can use the formula. But I'm going to show you on some of the above problems what you can do that's a little easier. Okay, so let's start with number 1. Up here I'm going to do several of these. You just did the Pythagorean theorem on your worksheet that you had after your test, and you were supposed to work on it on Wednesday. Well, the distance formula just comes from the Pythagorean theorem. And here's how, let me see if I can explain it by looking at number 1. Here's an endpoint here. Oops. Let me get a color, okay. Here's an endpoint here, and here's an endpoint here. If I go to the upper one and I drop a line straight down and a line straight over to that point where it started, I've created a right triangle. Now it's so tiny on this video, I'm going to be counting off on my worksheet that I've got here that I'm using. I took a picture of it. You're going to want to look at your worksheet. So if you count the side, you can label the sides of this right triangle just by counting the sides. For instance, the base of that triangle is 1, 2, 3, 4, 5, 6 units. Okay, I'll write in blue. I just counted this and found out it was 6. Okay, now let me count the height of that triangle. 1, 2, 3, 4, 5, 6, 7. So the height is 7. Now if you remember, the Pythagorean theorem says a squared plus b squared is equal to c squared, and I can use it here because I've got a right triangle. When I drop that line straight down and straight over, I create a right angle. That's the right triangle. So I can say, oh, okay, well my two, remember A and B just represent the legs of the triangle. The distance here is C. It's that hypotenuse of that right triangle. That's how somebody came up with the distance formulas. They just kind of broke apart the Pythagorean theorem and made it easy for you to label points and shove them in a formula. But really, where it came from was that we got a right triangle, and we can find that distance using the Pythagorean theorem. So one side is 6 squared, and the other leg is 7 squared, and I want my hypotenuse, and that's my C. I could have called it D for distance here, and it would also have made sense. So 6 squared is 36, 7 squared is 49. And I use the Pythagorean theorem, I add those up. Let's see, that's going to be 15, carry 1 is going to be 85 is c squared, but I don't want to know what c squared is. I want to know what c is, so I'm going to square root both sides to solve for c. And let's see, let me go over here and factor 85. I know 5 goes into it because it ends in 5. Okay, 5 goes into 8 one time with 3 left over. 5 goes into 35 17 times. Hey, those are prime numbers, aren't they? In this case, I can't do anything to reduce this, so I'm just going to say my answer is the square root of 85. It says round your answer to the nearest tenth. I would rather, honestly, have the radical always, unless I tell you for sure on a test or quiz, give me the decimal answer. I'll go ahead and put this in my calculator. My exact answer is C is the square root of 85. If I want to round my answer, if I want to approximate my answer, kind of give you a number that maybe would make some sense to you if you were measuring for some reason, when I square root that on my calculator, I get about, again, this is an approximate answer. The answer above is a better answer because it's an exact answer. When I round that on the calculator to the nearest tenth, I get about 9.2. Okay? So if you ever see me on a worksheet give an exact answer and it asks for a decimal answer, just know that, you can plug that in your calculator and get the answer. Okay, let's do, now there's some of them where they're trying to trick you. Look at number 5. You don't need to make a right triangle on 5 right here. You're just going to count the units. The distance is just 1, 2, 3, 4. If you count from here to here, then that's just 4 units. So number 5, don't make a triangle out of that. You can't make a triangle out of that. It's a straight line. Since if you ever have a horizontal line like this or a vertical line, they're real easy just to count off. You don't need a theorem. You don't need a distance formula for that. So, just kind of make sure you're using kind of your common sense about things like that. Look at number 3. I could drop a line down there and drop a line over and make a right triangle. And of course, that's hard to count. because it's so small, but if you're looking at your worksheet, on that little right triangle, the base of that right triangle is a 2, so let me put a 2 here. And the height of it is 1, or it's 1 unit up. And my distance is going to be the hypotenuse of that right triangle. Okay, so I'm going to call it C because it's the hypotenuse, and I need my Pythagorean theorem formula, a squared plus b squared is c squared. All right, so my two legs are 1 and 2, so I'll just put 1 squared. Doesn't matter which one I call A and which one I call B, does it? So all right, a squared plus b squared is c squared. 1 plus 4 is c squared. 5 is c squared. If I want my exact answer, I'll square root both sides. My c, my distance, my hypotenuse of my right triangle is square root of 5. That's my exact answer. Now, if you're checking on the worksheet, though, it tells you to round to the nearest tenth. So they're going to give you an approximate answer. All right, so let's see what that is in the calculator. If you square root 5, you get around 2.2. So I'm going to put it's about 2.2. And so that's what you'll do for checking on this worksheet. So this is all you're doing. There is another video to cover problem like 25. You're only doing the odds here. Notice on number 13, just if you're flipping over, it's a horizontal line. Don't make a right triangle out of that. Don't use the Pythagorean theorem. Don't use a distance formula. Count it off. Make your life easy, right? You could always draw these on a sheet of graph paper, but I'm not going to give you a sheet of graph paper on a test or a quiz, and I'm not going to provide graph paper for the ones here that are just listed as points. If you've got it and you want to use it, you can. I would really prefer that you be using the distance formula because there's times, especially if you go on in math and you get into harder math, that you're going to need the distance formula for other things. So you really need to be practicing some without them being on graphs in order to do them, in those situations.